Hello everyone, I want to use this video to talk about the solution for chapter 6 worksheet. For question number 1, number 2, both of them related with empirical rule. Okay, so I want to give a quick review for what's mean of empirical rule. For empirical rule, that's mean if we have a normal distribution with mean equal mu, with standard deviation equal sigma. So standard deviation is sigma. For the mean is equal mu. From mu minus 1 standard deviation to mean plus standard deviation, we have 60% of observations. 68% of observations. From, how about I use another color, from mean minus 2 standard deviation to mean plus 2 standard deviation. Plus 2 standard deviation. From this part, from here to here, we have 95% of observations. And from, for example, here from this part, this is the mean plus 3 standard deviation to mean plus 3 standard deviation. For this part to this part, we have 99.7% of observations. So we can translate this graph in mathematics language. That means if we are looking for the probability for x less than mu plus standard deviation bigger than mu minus 1 standard deviation, we have 60% of observations. If we are looking for the probability for x less than mu plus 2 standard deviation bigger than mu minus 2 standard deviation, we have 95% of observations. If we are looking for the probability for x less than mu plus 3 standard deviation bigger than mu minus 3 standard deviation, we have 99.7% of observations. So this is information we can get from empirical rule. Empirical rule is very useful to find the probability with special value of a random variable like mean, minus, plus 1, 2, 3 standard deviation. For the value of x between other values is not mean plus minus 1, 2, 3 standard deviation, we cannot find the probability. If we are looking for probability, we need to use a calculator or we need to check a z-table. Now we can go back to our first question. What is our first question? We are looking for the percentage of the bulbs have lifetimes that lie within 1 standard deviation. Within 1 standard deviation, that is 68%, right? And for number 2, we have GPA normally distributed with mean equal 3, standard deviation equal 0.5. What percentage of students at college have a GPA between 2.5? 2.5, that is 3 minus 0.5, and 3.5, that is 3 plus 0.5. So we can say this question is equivalent to how many percent of the students at college have GPA within 1 standard deviation. For 1 standard deviation is 68%, right? So for number 1 we choose A, for number 2 we choose C. For number 3, we have 2 questions. For the first question, we are looking for the 90th percentile. Okay, if we are looking for the 90th percentile, that means probability is given. Probability is given. Okay, so now I want to have a quick review for 2 functions we can use from our calculator. So nowadays we don't need to check table to figure out the probability related with normal distribution or percentiles related with normal distribution. We could use our calculator to help us. And for calculator, we have two functions. In fact, we have three functions related with the normal distribution. They are normal, PDF, normal, CDF, and the inverse norm. Okay, so if we are looking for probability, we use CDF. Okay, so if we want to find probability, we use CDF. If probability is given, we will use inverse norm. Okay, and for PDF is a kind of a garbage function. We never use it. Okay, we don't need to use this, so it's useless. We just use CDF and the inverse norm. And for number 3, let's go back to have a look at number 3 very quickly. Number 3, for A, we are looking for percentile, and for B, we want to find the percentage. Okay, so what's the meaning of percentile? Percentile, that is, if we have a bell-shaped curve, our random variable follow normal distribution. 90 is a percentile. That means I have 90% of observation less than this specific value. So if this part I have 90% of observation, and for this random variable value k, we call it 90th percentile. Okay, so similarly, if I have this part, if I give this one, this is definition for 20th percentile. So that means I have 20% of observation less than this number. So it's kind of, we already have the probability for this part. This part is 20%. Okay, so if we know this, for A, we are looking for the 90th percentile. That means probability is given. So we can use inverse norm. Probability is given, we use inverse norm. I will use a short video to show you how to get inverse norm. Okay, so this is my calculator, and this will be better. Okay, this is my calculator, so we can use this button, turn on the calculator, and then second distribution. Okay, second distribution, we can see we have normal PDF, normal CDF, and the inverse norm. So as I said before, normal PDF, we never use it. Normal CDF, if we are looking for probability, we use this function. Inverse norm, that is, if probability is given, we use this function. And for this question, we have the probability is equal 90%, so we press enter. And when we press enter, it requires us to input 3 numbers. The area, okay, so for this part is very tricky. For the area, we need to input the area to the left of the value we are looking for. And for the mean standard deviation, it gives us. So let's have a quick look at what is the mean. The mean is equal 80, standard deviation is equal 8. So now I can input 0.9, or you can use 90%. The mean is equal 80, and the standard deviation is equal 8. Press enter, press enter. So this is output. So for number 3A, this is our final answer. Okay, and for number 3B, what percentage of students score less than 90? So we are looking for percentage. So that means we are looking for the probability. Now we need to use the function normal CDF. So second distribution, normal CDF. Okay, we highlight the normal CDF, and then it will require us to input 4 numbers: lower, upper, mean, standard deviation. For the lower, we are looking for less than 90. Less than 90, so that means we don't have the lower limit. We will use negative 10 to 99 as our limit. And lower than 90, so upper bound is 90. So we import 90. Import 90. For the mean is equal 80. Standard deviation is equal 8. So we can press enter. Press enter. You can get this number. So 0.8944. That is the solution for B. Okay, 0.8944. So now I want to give you a quick summary for the function from calculator for this part. So if we are looking for probability, we use normal CDF. And for normal CDF, we need to input 4 numbers. We call them lower, upper, mean, and standard deviation. Mean and standard deviation is always given in the question. So the challenge part is how to find the lower, how to find the upper. So for example, if we are looking for the probability for x between A to B, A is the lower, B is the upper. If we are looking for the probability for x less than a number, it's kind of we don't have lower. We can use negative 10 to 99, a very, very big negative number to approximate to negative infinity. Use this number as your lower. And the same as before, use B as your upper. Okay, if we are looking for the probability for x bigger than A, we don't have upper, right? We only have lower. So A is lower. We don't have upper, so we will use 10 to 99, a very, very big positive number to approximate to positive infinity. So this is your upper. Okay, so this is how we use the function normal CDF. Another function for this part we need to use is inverse norm. Okay, when we use inverse norm, we need to input 3 numbers. And for these 3 numbers, we call them area, mean, and standard deviation. Same as before, for the mean and the standard deviation, you can always find it in the question. The challenge part is how to find the area. Okay, and for this area, it represents, if we are looking for example, the value of k, for this area, that is to the left of k. Okay, so that is to the left of k. So if we already know we have 20% of observations bigger than k, how to find the value of k? We need to input 80%. We always need to input the area to the left of this number. Okay, so this is very, very important. If you input the area to the right of the random variable we are looking for, it will lead you to the wrong answer. Okay. Number 4, we want to find the first quartile. Okay, so this is our question. First quartile. What's the meaning of first quartile? A quick review for the definition of a quartile. So if this is my bell-shaped curve, quartile, that's the number divided our data set to 4 equal parts. So first quartile, that means to the left of this number, I have 25% of observations. Okay, so it's kind of first quartile, that is the same as the definition for 25th percentile. So the probability is given. We need to use inverse norm. Inverse norm, we need to input 3 numbers. The area 0.25. The mean is equal to 235 hours. Standard deviation is equal to 7. Input this into your calculator. I got this as my final answer. So if you understand number 4, number 5 is very similar to number 4. We are looking for the 82nd percentile. So still use inverse norm. and input 0.82 as the first input, and the mean is equal 8.9, and the standard deviation is equal 1.3. So I got 10.09 from my calculator. So this is number 5. Number 6. Number 6, we have the mean, we have the standard deviation. We want to find the probability for x less than this number. So we are looking for probability. So normal, CDF, minimum, maximum, mean, and the standard deviation, right? And for the minimum, we don't have lower bound. We use negative 10 to 99 as our lower, and for our upper is 53. And for the mean, it gives us, for the mean is equal 60. Standard deviation is equal 4. After calculation, you will find out that the answer is D. Number 7. Number 7, similar to number 6. We are looking for percentage. We want to find the probability. So same as before, we use a normal CDF. We need to input 4 numbers. And for these 4 numbers, greater than, our keyword is greater than 0.32. So 0.32 is our lower. Our upper, we don't have an upper, so 10 to 99, that is our upper. For the mean, it's equal 0.3. And for standard deviation is equal 0.01. So after calculation, we can get it's equal B, the probability equal B. Okay, this number. For number 8, so this is solution for number 7. For number 8, what percentage? So probability question again. So normal CDF, input 4 numbers. And for the first number, we have the keyword less than 900. Less than 900, so that means 900 is our upper bound. We don't have lower bound, so negative 10 to 99, that is our lower bound. And for the mean is equal 1100. And for standard deviation is equal 150. So input this number into calculator. After calculation, we will get C for number 8. Number 9, we are looking for probability again, right? So find the probability. If we are looking for probability, normal CDF. Number 9, normal CDF. Input 4 numbers. The first input is lower, between 200 to 275, and the mean is equal to 200. Standard deviation is equal 50. So input this number into calculator. Calculator will give us output. C will be the right answer. And for number 10, what percentage of legal quotas will be rejected? So what percentage? The keyword is percentage. So that means probability question. So normal CDF again. We are looking for the percentage will be rejected. What's the meaning of rejected? For the vending machine will only accept the coins weighing between this and that. So if we are looking for the probability of the quarters will be rejected, we can find the probability for the quarter will be accepted. 1 minus the probability for accepted, that is the probability for rejected, right? And how to find the probability for accepted? We know if the weight of the quarter is between 5.48 gram to 5.82 gram, this will be accepted. And the mean is 5.67, and for the standard deviation is 0.07. So if we input this into our calculator, it will give us the probability of accept. So if we use 1 minus the result from this part, use 1 minus the result from this part, we will get the probability of rejected. After calculation, we can get is equal B. Okay, so this is the solution for this worksheet. If you have any question regarding this chapter, feel free to email me or have a discussion with me on Teams or set up Zoom meeting with me, okay?